Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wassalatu wassalamu ala rasulillah amma ba'du. Alhamdulillah, in this morning we can continue our class and Alhamdulillah we can still continue until this point. And of course, before we start our lesson and we start our discussion, we should begin our lesson with praying together. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Rabbana zidna ilma warzuqna fahma. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Alright. And now we are almost finishing discussing about the probability. And is there any other question about probability? And after this topic, is there any suggestion about what is the next topic we have to discuss? And do you ask or curious about some topics? Or if you have an interesting problem that you want to discuss, then you may throw it to this discussion. Okay, that's right, about graph theory. Okay, that's great. And then about the last discussion, before it, in the past meeting, I have implement the problem O, that there's a bug. Anyone knows where is the bug? In the last meeting, my sample output is still incorrect. Then how to correct it? And I think Abdullah Isfaq already got accepted. And where is my bug here? The bug is on this formula. I already implemented here, but I forgot that the value of j here means j%, right? It means we have to divide it with 100. So this is not just j, but j divided by 100. So the formula become like this because all of them is j here, so I put it in the last computation, or actually I can put J outside too. And then because here we have J squared and divide by 100. So we have to divide another 100 here. Okay, so the formula become like this, and I have just input with the sample and the output become correct. Okay, and then for the final problem, I think I not yet explain to you about the detail of the solution. And now in this problem, if we have some string, let's say string S, then we want to construct a graph with this pattern or with this rule. There are 3n plus 1 rocks with index 0, and then 3, 6, 9, and so on until 3n. And then here if the character in string is b, then the pattern will be like this. Let's say this is not 1, this is not 2. Did you understand what this formula means? I mean, if there is 1 and 2 here, the graph will be like this. Okay. And then if the character is O, then the graph will be like this. And if the character is N, then the graph will be like this. Okay. And then in order to simplify the graph, sorry, I have to conclude what we want to find. Here, unfortunately, the string is not given at once, but the form is like this. We only have a string T with size L and then an integer M. And then the string S is a combination or concatenation between some T's here until M number of T. So if string T has size L, so the size of string S is L times M. Okay. For example, L is 1 here and M is 2 and the string T is just N. So we want to repeat twice here. So the string will be like this. Okay. And there are already some suggestion about the topic. Okay, we will discuss it later. Okay, then after this point, did you understand about how to get the string S? The input is like this, and then we can conclude what is the string S. Okay, and then after we get the string S, then we will construct a graph like this based on the string. If the string is just n, so all of them is n like this. Okay, and then there are some queries, k queries. There are 3 queries. Each of query means what is the probability if we start from this node and then we want to win the game. Let's say this is a game that we start at some points and then we want to move with the same probability. Let's say from here, then the probability will be a quarter, 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 and this is quarter. The probability will be same to move to the adjacent. Of course, based on the degree. If the degree is 3, so the probability will be 1/3, like this. Okay, and then will win the game when we reach the node 3n, and we will lose if we reach 0. Okay, then what is the probability we can win the game? For example, for this sample, the index will be like this. So if we start from node 3, let's see here, the graph is symmetric, right? Between left and right is just same. So of course the probability to win to the right and to lose to the left is exactly same. Okay, so the probability is half because we want to modulo it with something. So half means this modulo plus 1 divided by 2. So if we plus 1 divided by 2, so equal to 5e8 plus 4, just like this. Okay, this means the probability is a half. And then what if we start from node 1? Then start from node 1, there is no other option except we have to move here and we lost the game. So the probability is just 0 because we always lost. And how about the if we start from 5 here, so we can just move it here, so we always win. So the probability is just 1. Okay, and also for the first example, graph looks like this. We start from node 8, so we must win here. Okay, then how to solve this problem? because if we see in the constraint, the size of L is small, but the size of M is 10 to the power of 9. So if we want to create string S, the size will be maximum 2 times 10 to the power of 12. Okay, it is impossible to create manually. Anyway. Okay, but then we have to make it simpler. So let's see for each character, let's say character P, this this graph is equal to this, right? And then what about N? The graph will be like this. And we know that because this is uh dead root, right? Or dead end, because this is a dead end. So if we go there, then we have to go back. Okay. So if we are in this node, then the probability to go here is 1. So if the query is asking what is the probability if we start here, so the probability will be same as the probability if start from here. Okay. And then we know that if there is a graph, let's say there are some branches here, and then there is a dead end here, then it is just same if we remove it. Okay, the probability will be same. So let's say there are 3 other road here. So the probability will be just a quarter for each node. But we know one of them is dead end, is just dead end. So after go there, we will go back here. So what is the probability to go to the A, B, and C? The probability of A is just like this. Let's say this is dead end. It is allowed to go to A directly, and then the probability will be just 1 divided by 4. Or we go to the D first and then A, and the probability will be 1 divided by 16. Or D and then D again and then A, and the probability will be 64 and so on. So the actual probability will be 1 divided by 4 plus 1 divided by 16 plus 1 divided by 64 and so on. And then we can solve it using geometric series. Then the result will be 1 divided 4 divided by 1 minus 1 divided 4. 1 divided 4 divide 3 divided 4. Then equal to 1 divided by 3. And the same way we will use for the rest of node. So the real probability will be just 1 over 3. and we can remove it because this is dead road. So that means we can just remove the dead road here. Yeah, because the tree this tree will be have the same probability, right? So it must be 1 divided by 3. So we can remove all of the dead end. So if the number, sorry, if there is a character n, then will be just like this. Okay, we can make it just like this. We remove the dead end. Okay, until this point, do you understand? So the curve will be just line curve if there are just p and n. How about O here? The pattern is like this. What will be the probability? And the good news is this will be also equal to this. Why? Because if we have a line graph here, then the probability go to the left and go to the right will be just half and half. Okay. And then what if there is O here and there is O here? Then the probability to go here and to go here will be also half and half, right? Okay, and then what if like this? We will prove it that the probability is also here half, here also half. So that means we can ignore whether this is linear or this is or there is a cycle here, regardless what is the form, the probability is always just half and half. Okay, and then we can make it all just same, that is linear graph like this. Okay, how to prove it? Let's make a graph here. Let's say this is a win position, this is the loss position. Then what is the probability to win? And we know that this is 1 over 3, 1 over 3, 1 over 3 here. Let's say the probability of win if we start from here is P. And then the probability if we start from here is R. And of course this is also R because it is symmetric. So we want to find what is P. And we know that P is equal to R divided by 3 plus R divided by 3. And then R equal to P divided by 2 and plus 1 divided by 2. Okay, that's right. Okay. Why? Because from B, with the probability of 1 divided by 3, we will lose. So just multiply by 0. Okay, and then with the probability of 1 over 3 also, the probability to win is R. So R divided by 3. Then plus R divided by 3. How about R? The probability of half is go to the P. And with the probability of half, we win. So multiply by 1. Okay, so this is the formula. Then how to solve it? We can just substitute here because all of them is r divided by 3. We can just multiply by 2. And what is r? R is equal to this. Okay. And then just solve it. We can move it here to the left side, and then we can cancel 2 and 2 here. Okay. So if we cancel 2 here and here, so 3 times p equal to p plus 1. Okay. And then we move p to the left side. 2 times p equal to 1. And then we move to here, p equal to half. Okay, finally, we have just proved that the property to go to the right and to go to the left is the same. Okay, so we can always make the graph become just a linear graph. Then what if there is a query that asking what is the property of this? Then we can just make it a half times this and a half times this. Okay. All right. And then what is the probability of a linear graph? Let's say there is a linear graph with length n, let's say. Then what is the probability of each of them? Let's say the probability is here p0, and then here p1, here p2, p3, and so on until pn. Okay. P3 means what is the probability if we start from node 3 to win the game? Okay. And then how to compute them? To compute all of them, we have to know about it. We know that pi equal to pi minus 1 plus pi plus 1 divided by 2. You know, if we are in node I, then with the equal probability, that is a half, we can move to the previous node or to the next node. Okay. What does it means? We can move to here to the left side. So the formula will be like this. And then we can make it pi plus pi here. And then we can move pi to the right side and pi minus 1 to the left side. So the formula will be like this. Okay, do you agree with this formula? All right, and then what does it means? It means the difference between this and this. Let's say the difference is a. So here the difference is also a. Here also a. Here also a. All of them is same because this formula. The difference between I and the previous and the difference between the next and I, this is same. Okay, so all of them is same. That's it. There will be an arithmetic sequence. And what is the probability of the first node? Sorry, not 0. the probability will be 0. Yes, that's correct. Because we already lost before we move to any node, any other node. Okay, how about the last node? The probability is just 1. Okay, and then we know because the length is n and each of them the difference is a, so we know the total difference is a times n. So what is a? A times n equal to 1 minus 0 plus 1. And then, so what is a? That's right, 1 divided by n. So because a equal to 1 divided by n, then this is will be 1 divided by n, 2 divided by n, 3 divided by n, 4 divided by n, and so on until n divided by n, and this is 0 divided by n. Okay, until this point, you got it. So we can solve this problem with all of the observation. So we can just find the length of the graph. So the length will be like this because k times l is small, so we can just brute force it. Yeah, of course there is a faster solution, but as long as we still less than 1 second, it is okay. Okay, so the solution will be just like this. Let's say we want to input the one of the variable here, and then s, sorry, t, and then for each one until k, we want to input the node, let's say p. Okay, so we can make it long also, lmkp and a string g, and then the modulo is just like this. Okay, and then I think we still need this function since we want to find the probability with modulo something. And then let's say we want to know the length, or maybe we can define the case where the character is all like this. Let's say if the length is n, so here is something divided by n, and this is something divided by n. So this is just p plus half divided by n, right? So this equal to p, yeah, to p plus 1 divided by 2n. And this is 2p divided to n, and this is 2p plus 2 divided by 2n. Okay, so we can multiply the length become 2, so we can directly make it in the half between them. Okay, so let me create an array here. Say array A, and then I will iterate all the string t. If the character is p, so there are three cases. If the character is p, then the case will be like this. If this is p divided by n, then this is p plus 2, and then this is p plus 4, and then this is p plus 6. Note that we already multiply it with 2. Okay. Did you understand? Okay. So this is not 3i, and this is not 3i plus 1. This is 3i plus 2, and this is 3i plus 3. You can check with the description. So that means the probability of 3i plus 1 is equal to probability of 3i plus 4, right? And then this is plus 2, and then this is plus 6. And then how about if equal to O? Okay, maybe I will explain again after read all these three cases. So I will make the formula first, and then I will explain to you. We can ignore else because all of the case is different. Okay, so what is array A? Array A means like this. If we have a line graph here, 0 means here, 1 means here, 2 here, 3 here, and so on until n. So if we have an O here, let's say at some point the character is O. So that means we can imagine that the graph is like this. Okay. So if the probability here is 3, let's say, then here will be 3 plus 1. This is will be 3 plus 1, and then this is 3 plus 2. Okay. So we convert from the original graph into line graph here. What will be the index in the line graph? Okay. So if it is P, or let's say this is N, the graph will be like this. This will be also 3, this is also 3, so just same. And then this is plus 2. Because we will make it through here in order to handle this case, right? So we imagine that the length is just 2. And then this is in the middle between them. Okay. So if the curve is just line, then the length is 2. And if the curve is like this, then the length is also 2. So the length here just 1. Okay. So that's why if O, this is +1, and +2. While if the character is N, we want to plus it by 2. This is +0, +0. This is just the same. And this is +2. Okay. This is N. How about P? The P is just like this. All of them with length 2. So if this is P, then this is P plus 2, P plus 4, P plus 6, like this. Okay, you got it? All right. So what next? After that, we want to answer the queries. So the last character will be on a 3 times L, right? And then because we multiply it by M, so we can just multiply it by M here. And if we input P here, the value of P may be greater than 3L, right? So we have to modulo it by 3L because it will be periodically until 3L, right? Until 3L, and then there is the same graph until 6L and so on. So the exact not it will be P modulo 3 times L. And then the probability, of course, divided by the total length. The total length is M multiplied by A times 3 multiplied by L. Okay, sorry. I think we also have to plus it with A times 3L multiplied by B divided by 3 times L. So if we are in the second group here, the node is like this, the modulo. This is the index. And then plus A3L here. Okay. And if we are in the third group, then plus 2 times A3L. Okay, so the formula will be like this, and we can make it simpler by using modulo here. This is the divisor, let's say. The divisor will be always divided by m times a 3 times l, like this. And don't forget to put modulo here, because the value can be larger. And if we don't use modulo here, so this formula can be overflow. Okay, for that we can just multiply it with t, and then a is small and this is also small, but the value here may be greater, so we have to modulate first. So this is the final formula. Okay, so the complexity is just OL plus K and times logarithmic mode. So if we try to input the sample, probability is just 1. In the second sample, half, 0, and 1. Okay, all of them are correct. And the probability is just L plus K logarithmic mode. So this is just 2,300 multiplied by 30. So just around 10,000. And this is so fast. And then until this point, any question about the last problem? Okay, great. And then here there are some suggestion about the topics, about our next topics, about graph theory or some data structure such as segmentary or or lazy segmentary. And then I think there are bandwidth tree also, and also Chinese remainder theorem. which is about number theory, right? So for your information about segmentary, the segmentary is a big section in the commodity programming topic. So the topic is so much, and there are too many problems that can be solved by segmentary since it is so flexible to solve any various problem. And the segmentary itself some has sorry has some modification, like let's say a simple segmentary or lazy segmentary, and then there is also dynamic segmentary, and then persistent segmentary, and there is also range segmentary, and then segmentary bits, and then segmentary two-dimensional, and there are still many other modification. We also can combine them or segmentary on three. What else? Maybe convex hull on segmentary. The topic will be so wide and not always discuss all of them in one time, but we can discuss it one by one, and then we discuss another topics, and then discussing again about the other segmentary, and then discussing another topic again, and so on. So I think it is also better if we discuss some simple segmentary from now. And then usually if we want to discuss segmentary, we start from Fenwick tree first. But I think because you already know segmentary, so we can we can skip it or discuss it again later. Okay, that's great. You already know the simple segmentary. Simple segmentary means segmentary that can query range or range query and point update, right? Is it correct? With segmentary, we can operate an array. We can ask, let's say, what is the sum from L to R, from L to R, or what is the maximum between them, or what is the let's say what is the maximum x minus y for all xy between them and so on. And then we also can update a point, so we can edit this into another value, let's say from 5 into 8 and so on. That's still update point, not update range. Then how about range update here? If you want to update from L to R, all of them, let's say, plus by 5. So if the initial array is like this, let's say, so the array will be modified into this. Okay. Do you know how to handle it if there is a range update? Yeah, of course, with lazy segment tree. Okay. So the difference between simple segment tree and lazy segment tree is just on the update. All right. And then how to implement it. Before that, I want to know how you implement the simple segment tree. Okay, maybe some of you may implement or just copy paste your template or just find some problem that you already solved about segment tree. Maybe not just one of you, let's say you will also implement it and the other, let's say Abdullah also, and the other, all of you can try to implement. If you ever implement it before. If you haven't studied before, so not a problem. I just want to know how you implement it. Okay, that's great. Okay, most of you use left inclusive and right exclusive, right? For me, um, I always use both inclusive, but of course, all of them is accepted. And my friend also, my friends in my country also always use both inclusive. Okay, nice. Okay, Rafiullah use both inclusive, same as mine. And to find LC using plus, and this is faster. Actually, the complexity will be same, and this is not too important, but I just want to explain that this is will be maybe, yeah, will be lower the constant here, will be some millisecond faster. And actually, there is another faster way. This is the slowest, and then this more faster, and this is more faster. This is fastest. Okay, there are the three ways, or maybe there is another ways. And this is the slowest, and then this is more faster, and this is the fastest. Okay, if you want to, but this is not too important since the complexity will be still same. This is just if we want to decrease the constant. Let's say if our submission is 1 second plus 8 milliseconds. So if the complex is if the time limit is just 1 second, so we want to decrease the constant, so we can make it like this. Hopefully our runtime will be lower, let's say 99 like this. Okay, but usually the time limit will be loosened, not too strict like this. Okay, all of you already implement it. That's great. As I'm also using but inclusive, so hype as well. And of course, all of them is correct. You can use inclusive or exclusive. And the implementation will be a little bit different. Yes, this is n times 4. And this is faster also. Faster than times 4. We can shift left too. So this is the slowest, and then this is the faster way. And also to find the middle like this. This is the slower way. This is the faster way. But again, this is just reduce the constant, but not the complexity. The complexity is still same and logarithmic n. So this is not too affecting. Okay, so you already know about the concept and why there are so much problem that can be solved by segmentary, because this is so flexible. This is not just can solve how to sum them, but also maybe can find the maximum. We can just edit this into maximum. and also minimum. Of course, if we want to find the maximum, then this is minus infinite. And if we want to find the minimum, then this is return infinite. Okay. If just sum, then 0. If it is product, so this is 1. Okay. So this is based on what is the result if the array is empty. Okay. And also there are some various problem. Let's say like this. The operation is not just simple simple as minimum, maximum, plus, XOR, multiply, greatest common divisor, and so on. But sometimes the operation is more complex. Let's say like what? Maybe like this. What is the maximum a minus b for all x, sorry, for all a b between, sorry, what is the maximum a x minus a y, and x and y is between L and R? How to find it? Using segmentary, of course. That's right. We can store two variable at once. We can make a pair or a struct that store minimum and maximum, and then the result. And then if we want to query, we can just find the minimum between minimum and the maximum between maximum. And then after we query arrange, then we can just use the maximum and then minus the minimum. Okay. And then what if the query is like this? Okay. Or maybe this is less than or equal. Anyone knows how to find it? Let's say x have to be less than or equal to y. So if the array is like this, let's say 5195, then what is the result? If we query here, what is the maximum? 4, that's right. So how to compute it? Using segmentary also. And this is not 8 but 4, since x should be less than or equal to y. Then how to find it? No, there is no binary search here. We just using simple segmentary. And of course, this also can be updated. Let's say we update this point into 10 and then we query again and the result become 5. Okay. We can update point and query range. And the query is like this. Just using segmentary, not using another algorithm or data structure. if the past problem we store minimum and maximum, here if we make it the problem like this, then we have to store three values: minimum, maximum, and answer. Okay, this is the hint. Did you get the idea? The answer is just the maximum of this. Okay, so some people. Okay, you got it. What is the formula? What is the formula for answer? That's right. Okay. Yeah. But the idea is correct. So, but the formula, yeah. Okay. Then how to implement it? Sometimes we have to use struct here. Let's say struct segment. The value is ans, max, and min. And then we have to make a join function between x and y. What if we want to join a segment x and y? Then what will be the result? So r dot ends will be equal to r, sorry, the maximum between x dot max minus y dot min, and then the maximum between x dot ends and y dot ends, and then r dot max equal to max between x dot max and y dot max, while r dot, sorry, dot max, r dot means equal to the minimum between x dot means and y dot means. Okay, that's it. So this is not just integer but as struct. So if we want to query, the query is segment, and then the return is we want to join them. And then if we want to output, then we will get with some value. Let's say r, and then this is 1, this is 1, and don't forget to put dot ends here if you want to output it. Okay, how about update? Update means, oh, you forget to, sorry. Oh, that's correct. Okay. But here, if you want to update such problem, we have to make it like this. Sorry, this is S equal to join between 3 to S and 3 to S plus 1. Okay. And then this is not return 0, but return 0 minus infinite infinite. So this is the best value of the best value of the result, or we can also make it minus infinite as well. This is the best value of maximum, and this is the best value of minimum. Okay. And what if L equal to R? We can make it maybe use to type space. Okay. We can make it 3S equal to what? The answer is start from 0, and then the maximum is just value and also value. Okay. Until this point, did you understand? All right. After that, yeah, what is why the formula is like this? Where did it come from? Yeah, because if we join two case, there will be three case here. The case where all of the x and y here, or x and y here, or x here and y here. Okay. And there is no case where y here, x here. This is invalid. Okay. If the case is like this, so the result will be x ans, x dot ans. This is the maximum, and then this is y dot ans. Well, this, in order to achieve the maximum, so we have to use the maximum ax and the minimum ay. So we use this formula. Okay, that's all. After that, sometimes the problem is like this. We are given a string that consists of bracket, some of them open bracket and some of them close bracket. And then sometimes we query what is the longest subsequence that is the correct bracket. Do you know what is the correct bracket? Let's say this is the correct bracket. This is the correct bracket, right? Let's say this is also a correct bracket, but this is not. Okay. What is the longest subsequence of correct bracket here? And we also can update the bracket from open become close or from close become open. Okay. Do you got Did you get any idea how to solve it with segmentary? Longest subsequence, not subarray. Actually, yeah, of course not subarray because the option is only subsequence or substring because this is string, not array. But in this problem, we use subsequence, not substring. Okay, that's right. So we also have to store three variables. So we just need to store like this, right? Or let's say this open and close. The answer will be x dot ends and y dot ends plus, okay, then you have to find the formula to sorry, not multiply because we don't want to find the number of pair of the correct bracket, but the longest. So the formula is not like that. Yes, that's correct. We want to take the minimum. Then what is the formula of open and close here? Can you make the formula? This is open and this is closed. Anyone knows? Is it true? Just like this? If it is just like this, then the formula will be not just like this because some of them may be already have a pair. Let's say, okay, that's correct. You already get the idea. So I don't need to explain. We can just minus with this minimum, right? So let's say the number of new pair is like this. Actually, we can multiply it with 2 because they are pair, right? A pair of brackets. So we will multiply it by 2. And then this is not just the number of open bracket, but the number of open bracket that is not used or not used yet. Okay, so if some of them already used, then we can subtract it with that number. Okay, then you got it? Did you understand? Then all of them is still same. Maybe we have to modify this. We have to store the initial string, right? Let's say this is the string of bracket. Then we have to check whether this is open or close. If it is open, then we can close it. So the formula will be become like this. This is close. Okay. Else, sorry, this is just else. Else, then we make it open and the formula become like this. Or actually, we can just make it simpler that we can just swap dot open and dot close. Okay. After that, all of them is still same. This is also same, but here the length is 0 and there is no open or close bracket. That's all. Okay. Any question about the variety of segment tree? Maybe after that I want to create you another training about segment tree. Okay, and then how about range update? How to how to update but in one range, not just one point. Let's say we want to find the maximum, and then if we want to update, we may update every of them plus by k. Okay, then how to make that lazy update? We can make it like this. Maybe I will use the other implementation. Maybe I will use this. If you want to update in arrange, or sometimes I use like this. This is update and this is edit. Edit means just one point, while update means range. But it is just my style. And then how to update it? In order to update it, the parameter will be like this: v st n start n, and then not just index but index from L to R inclusive, and then this is value. That means we want to add all of them, all the array from L to R plus by value. Okay. While this edit means array in some index become value. Okay. And then let's make it maximum first. Let's say we want to find the maximum, not the sum. So this is just maximum. I think this is not return, but we have to put a value here. If you want to make a sum, then just return 0. If you want to find the maximum, you can put it 0 if it is guaranteed that all of the value is non-negative. But if the value is sometimes negative, we can make it minus infinite. Okay. What is infinite? We have to make it in the constant long here. Let's say infinite means 1 or 10 to the power of 9 if that is the maximum value. If the constraint allows until to the power of 18, then we solve make the infinite like this. Okay. And then we should make it maximum. Then how to update range at once? The implementation is like the query because we want to update range, while here we want to query range or range query. But this is void since there is no return value. And then here if out of range, then we are not updating anything. But if we update the whole range, then we have to add like this. First, sec p will be added by value, and so is the lazy added by value. So not only storing about the value, we also storing about lazy. So what is the concept of lazy? The concept is like this. If there's a segment tree, let's say there's an array with size n, and then we split it into two half, and then each of them become two half as well. and so on until become atomic. Okay, let's say this is segment 3. And then if we want to update some range, let's say we want to update from this until this. So at first, if we want to query, we can just query here and also here and also here, also here and here, right? But how about update? If we want to update, then we also have to update here, here, and so on. All of them is changing, right? So if we directly update all of them, then the complexity will be on, and it will causing time limit exceeded for some cases. Okay, for some problem, if the constraint is large. Okay, then how to improve it? We can update in just some segment here. And how about the other? The other we not updated yet right now, but we will update it them. We will update them sometimes when we need it. If we don't need the value, so no need to update them. Okay. So after we update some point here, we store some lazy. Lazy means some task that we have to do, but we are not doing right now, but we will do it later. Okay. Because if we do all of them right now, then it will causing time limit exceeded. So we will do them later. So when we will do them, when we want to access the child here, if we want to access this value, so because here there is a lazy task or pending task, so we will do them to all of the child, and the lazy become here. That means this job is done, and then there is still some pending task here. And then because we want to find the value here, so we will also do this lazy task. So this will be updated and lazy become here. Okay. What about this? Because we don't want to know the value of this right now, so it is not important to do this task right now. We can pending it later. Okay, that is the idea. So let me show you the implementation first before I explain the complexity and so on. Okay, but if you have a question, you can ask from now while I implementing this. So we just put lazy here, and don't forget, if we want to access the child, then we have to push it to the child. This is VSTN. Okay. And don't forget, if we have some lazy propagation here, we have also push when we want to query. If we want to query, then also we have to do the task first. Okay, what the push means? Push means we want to do the pending task. So if lazy v is equal to 0, then we can just ignore it because we don't have any task. But if we have some task, then we have to make it like this. Okay, and so is this. And also about the lazy, we also store the lazy of the child. And then don't forget to mark that this task is done. Okay, this is the implementation. You can just add this and then create this two function. Okay. Okay, there are some question. When we will get the range only this that yes, that's correct. We will update only if we want to get the exact value or every time we want to visit that node. Okay. So whether we are here or we are here, or if there is also edit point here, so we also have to push here. But if but generally if there is update trains, then we don't need update point since we can just make it L equal to R, right? Okay. Yes, Ayan asked. What for we pass this value? Okay. Yes, for this problem we don't need this. But in some other problem, let's say if we don't want to find the maximum, but we want to find the sum, what should we do? We don't need maximum, but we need sum. So the formula is like this. And here the base value is just 0. And what will be updated? This is not just value, but what? Anyone knows? The value of segment will be updated into value multiply what? Multiply. If you want to, sorry, if there is a range, the value is yeah, some value. Let's say just 1, 3, 2, 4, 5, 7. And then we want to increase each of them by 3. So if the previous sum is what? Is 22. Then after we update it, we want to add them by not just 3, right? But 3 times what? 3 times 6, right? That's right. Then what will be the formula? Segment plus value times what? That's right. N plus, sorry, N minus ST plus 1 if all of them is inclusive. Okay, that's correct. Not LNR because LNR is the range of the query and start and end. This is the length of segment, and we want the length of segment, not the length of the query. Okay, and then what will be, then here we will need the value of middle. Okay, so here we want to add by what? Do you know what shall we do here and what shall we do here? And well, the lazy is just same. If in this range we want to add by 3, then all the children also 3, regardless what is the length. But when we add to the value, we should multiply it by what? By the length, right? And what will be the length? The length is just, yes, that's correct. Mid minus st plus 1, while here n just minus mid. Okay, not plus by 1. Okay, because we use both inclusive here. Okay, and in this problem, we will need parameter st and n. Okay, so I think that's the discussion about lazy segmentary. Is there any other question? Okay, I think that's all for today, and please wait for the next contest and see you again in the meeting. So before we end our meeting, let's pray together. Allahumma anfa'na bima 'allamtana wa 'allimna ma yanfa'una wa zidna ilma. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum ala nabiyyina Muhammadin walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.